Okay, here we are with lesson 83, 3 problems. Practice B, practice 1, and practice 20. So in this first problem, what we've been asked is to see if there's a perfect trinomial, and if so, fully factor it. So I've already done the work here, but I'm just going to show you all the steps. So when we look at this, we look and say, oh, these coefficients and the constant, they're all divisible by 6. And so we draw the 6 out. And then what's left is n to the 4th minus 2n squared plus 1. Now we have to determine if this trinomial is fully factorable. And it is, because what we look at here, by seeing this, we're going to have n squared times n squared is going to be n to the 4th. And the positive 1, if we multiply two negatives, negative 1 and negative 1 together, we're going to end up with a positive 1. And if we add them together, we're going to look and see that those middle terms are going to be a negative n squared minus n squared, so that's going to be negative 2n squared, and that's what we had right here. So since this binomial and that binomial are exactly the same, we can shorten it and write it as n squared minus 1 raised to the second. All right, so that's the first one. Practice 1, what we're asked to do is multiply these. What's the product of these two binomials? Now, it looks kind of scary having this radical 6. We know that's not a perfect square, so we're just going to treat that almost as if it were like a variable. But we see here that radical 9 that's a perfect square. So what I did was I just turned it into 3, because 3 times 3 is 9. So the square root of 9 is going to be 3. And now we can actually have a much simpler FOILing process. And then we're going to add like terms. So let's do that. So we do firsts. And the first is 7 times 4, that's 28. And then the outer, this is negative 3 times 7, that's going to be negative 21. And then the inner, which is going to be 4 times radical 6, that's why we have 4 radical 6. And then the last, negative 3 times radical 6 is going to be negative 3 radical 6. Now, like I said, we're going to combine like terms. Here we've got the constants that when we combine them, they're going to be 7. And then we have our radical terms. So it's nice that we have positive 4 radical 6 and negative 3 radical 6 just ends up to being a positive 1 radical 6, but we don't write the 1. So it's the full answer here is 7 plus radical 6. Now, for this last problem, so I hope you have your books with you so that you can go back and take a look at these. This last problem, number 20, it's a word problem. I'm going to read it for you as I show you the Pythagorean theorem here. It says the length of the hypotenuse of a right triangle is found by adding the squares of the two legs and then making the square root. The sum of the squares of the legs for this hypotenuse, so this is the hypotenuse here, and these A and B are the legs. And so what we have in this problem right here is c squared as the hypotenuse. So knowing that, what we do is they gave us this equation, and all we're going to do is the same thing that we did right up here. We're going to take whatever we can, factor it out, and then see if we have something that we can factor a little further. So see how we have 16m to the 4th here. 16, this is divisible by 16, and there's m to the 4 hidden in that m to the 5th. And again, we have 16 times 100 is going to be 1600, and we have m to the 4th right here. So once we factor out 16m to the 4th, what we're left with is m to the 2nd and 20m and then 100. So we look at this and we say, oh, this is going to be a trinomial. It's probably pretty easy to factor. And it is. We were just going to look at this constant coefficient because this one's 1. So we look at the factors of that multiply to get to 100, but add to get to 20. And here it's 10 and 10. So that's pretty simple. We also see signs-wise that it's positive and positive, so we know that both of these are going to be positive. These are going to be the same number. They're going to be the same sign. And so what we can do is we can consolidate this m plus 10 raised to the second, just like how we did here. And then if we want to, we could leave it as 16m raised to the fourth, or we can remember that 16 is a perfect square of 4, and m to the fourth is a perfect square of m to the second. Oh, you know what? I need to fix that. M to the second. So it's not written real well, but there we are. So m to the fourth and 4 to the second would be 16. So those are your three example problems. I'm going to give you some other problems from lesson 83 for you to work on from the odds. Thanks a lot.